So in the last section, we looked at using liquid-liquid extractions to separate an analyte between two phases, between kind of your phase 1 and your phase 2. And we said that the analyte concentration was at an equilibrium between the two phases. Now, we also looked at extraction efficiency and showed that by doing a series of small extractions, one right after the other, we actually got better extraction efficiency than just doing one large extraction. So we're going to extend this idea into chromatography, where we want to be doing a series of small volume extractions, one right after another, between the two phases, phase 1 and phase 2. Now, in chromatography, we can think of doing this series of extractions kind of in a series of space, where we do one, we might move down a little bit, do another extraction, move down a little bit, do another one. And so we still have two phases here, but in this case, one phase is called the stationary phase and is not moving during these extractions. The other phase, called the mobile phase, is moving during these extractions. So what does this mean? It means we kind of do an extraction, and any analyte that ends up in the mobile phase, I'm going to abbreviate that MP, and not in the stationary phase, SP, when it's in the mobile phase, it can then be moving along with the direction of the mobile phase. The mobile phase itself is moving. So it will move along a little bit further and then hit another point where it will interact with the stationary phase again. There will be some kind of an extraction, some will be left in the stationary phase, some will be left in the mobile phase, and whatever returns to the mobile phase is going to continue moving, and so on and so forth. Okay, so how do we use this to our advantage? Well, if we have analytes that have different equilibrium, where some of them will prefer to spend time in the stationary phase versus in the mobile phase, these will spend a lot of time in the phase that is not moving. And so to take a period of time to get from one end of the column to the other end, where we've kind of moved from one end of the phase interactions to the other end of the phase interactions, is going to take more time because it spends a lot longer time in the phase that's not moving. But an analyte that prefers the mobile phase is going to spend a lot of time in the phase that's moving. And so at each of these extractions, it's more likely to end up in the mobile phase and keep moving its way down the column very quickly. So in this process, what we're ultimately going to be looking at is the relative attractiveness of an analyte to the stationary phase versus the mobile phase, and relating the time that it takes, or the distance along the stationary phase that it travels, to be related to its preference for the mobile phase or the stationary phase. Now, there's a variety of different options for stationary phases and mobile phases. And we'll talk about some of these combinations as we go through this class. So the stationary phase can be it can be planar, so in a two-dimensional plane. And so we can see this using things like thin layer chromatography. There we go. Or using paper chromatography. And in this case, the stationary phase is mounted on some two-dimensional surface, and your mobile phase kind of travels up. So here's my stationary phase, and my mobile phase would be traveling one direction across that phase. And so you get analytes that are separated from their starting line. They get picked up by the mobile phase, and some are going to move just a little bit because they're really attracted to the stationary phase, and some are going to move much farther because they're more attracted to the mobile phase. And we can visually see this as we look at the results on this two-dimensional planar stationary phase. Now in this case, when we're doing thin layer or paper chromatography, the mobile phase here is a liquid for two-dimensional phases here. But we can do things that aren't two-dimensional. So we can have the stationary phase be a column. We kind of have a three-dimensional space. So what this column is it's just kind of an open tube. And so in this tube, lined on the surface, we might have our stationary phase. And I always abbreviate this SP because I don't like writing stationary phase every time. So the stationary phase is adhered to the surface. And so our mobile phase flows through the center. Okay. And so as the analytes are flowed through, they're constantly moving, and so they can interact with the stationary phase at a number of points along the column. Okay, it doesn't happen just once, but again, we're doing a whole series of tiny extractions as it moves along this column. Now, what kind of a mobile phase do we use here? The mobile phase here can be either a liquid, like we saw with thin layer or paper chromatography, or it can be a gas. And we'll talk about liquid chromatography, which is traditionally using a column with a liquid mobile phase, or gas chromatography, where the mobile phase is a gas. Now I've drawn this as what we would call an open tubular column, where the tube itself, the column, is largely open, and you just have your stationary phase attached or adhered again to the kind of as a lining of the tube. But we can also have what we would call a packed column. And in this packed column, we have particulates. Okay? These particulates do not move. But what these particulates are usually some kind of silica that are coated in the stationary phase. And again, these do not move. These are your stationary phase. They have to stay put. Your mobile phase, which can again be a liquid or a gas, is flown all around and can take different paths, moving around all of these particles. And as it moves around, as the analytes move through, then they have interactions with the stationary phase on the surface of the particles. A couple of terms that we use with chromatography that you'll want to be aware of are, we call our mobile phase as it enters into the column. Okay, so we have our column here, and that's this kind of tube that we're using that has the stationary phase. When the mobile phase is coming into the column, we call this the eluent. And what's exiting the column is called the eluate. So if you see those terms as you're looking at different uses of chromatography, eluent is simply what's coming into the column before separation, and eluate is what's coming out of the column after separation. All right, so this is kind of the brief overview of what we're going to be doing in chromatography. And as we go through the rest of this module and the next module, we're going to be looking at different ways in which separation occurs, different ways to predict what this equilibrium is going to be, different ways of setting up our column using either open tubular or packed column, and what's going on with the separation of analytes that leads to to this equilibrium showing up as peaks, and how do we interpret all of that? So that's where we're headed in the rest of this module.